Okay, grade 12s, please make sure you've watched the first video on derivatives that I've posted. It's a separate set of notes. It's just really detailed and very step by step. So I'm going to be just going over this again. It's almost like a recap what I've done in the previous video. Please watch it. So the derivative, the gradient at a certain point on a curve, using the specific formula from first principles, is given by this formula. Right, so again, just a recap. Derivative means gradient at a point or gradient of a tangent at a point on a function. Right, and we use the notation f dash. So the first principles is the fact that we are using the derivative, the gradient, as your h value is getting smaller and smaller and smaller. The distance between your two x values are getting smaller until you end up with one single point. There's not two separate points that land on top of each other. And then using your average gradient formula that you've worked with. Right, so when we use the formula, we are finding the derivative from first principles. So there are shortcuts to this, but you use this method when they ask you to use the first principles method. Okay, so you have worked with this before in the pre-calculus worksheet. Now you're putting in the limit. I did explain that in the previous video. Please watch it. Otherwise, you're going to be a little bit confused. I'm just going through the steps here. So it says determine the derivative of f of x is equal to x squared plus 1 from first principles. So this is asking you to find a general representation of the gradient at any one point on this x squared plus 1 graph. Now this is a parabola that's sitting, x squared plus 1 is there on the y-axis at 1. So they want to know if you want the gradient at that point, at that point, that point, that point, any point, we want a general formula that's going to get it to us. Right, so the first thing you do is you write out your first principles formula, which is f dash x, or f of x, in the derivative format, is equal to the limit as h approaches 0 of f of x plus h minus f of x over h. If you still don't know what this is talking about, please watch the previous video. Right, so I normally do it on the side. They've done it up here. You write your representation for your f of x, and then you do the same thing, but instead where you see an x, you put in x plus h. So that was x squared, so now it's x plus h all squared plus 1. You FOIL or fail. It won't work if you don't FOIL it. FOIL, and then that is going to fit in to your formula. All right, so the first thing is your f of x plus h. I'm going to highlight that in green. Your f of x, I'm going to highlight that in blue. So you replace the green and the blue into the formula. Right, so pause your video, try it yourself, and then unpause it and see if you've gotten it correct. Right, so I've substituted in my green and my blue, and I've distributed my negative in, and I am at that step now. So the nice thing about this first principles is you can see very quickly if you've gone wrong, because you will always be able to get rid of any term that does not have an h in it. So the x squared minus x squared, the plus 1 minus 1, they will cancel out. So all you're left with is 2 hx plus h squared. Now the idea here is that you want to have an h-only set of terms so that you can factorize out an h and cancel that h in the denominator. Because if you try and put that 0 in now, you've reached the limit, it means that you are going to get a undefined situation. So I need to first factorize out an h. Then my h's can cancel. First, show me a step where you've got the leftover bracket without the denominator. You must have it in brackets, please. And then you can substitute in the 0. So this 2x is representing on this graph. So this is the graph again. Right? Any one point. So I'm going to pick this point. I want to know the gradient at that specific point, because remember, it's a curve. The gradient is changing. The slope is changing all the time. So I want to know very specifically at that point. If I was able to find the x value, let's say the x value is 2, I could then put 2 into that. So it's going to tell me my gradient at that point is 4. But then let's say I'm going to go over here, and this is going to be negative 5. So then I could put negative 5 into this general first principles derivative gradient and know that my gradient at that point on the graph is negative 10. Okay, imagine also you could draw tangents here and look at the tangent over here at negative 5 is a negative gradient straight line. And over here it's a positive gradient straight line. All right, so 2x is representing the general gradient for any single x value on this curve. Right, so here, given the function g of x equals negative x squared plus 3x minus 2, first thing says determine g dash x from first principles. So this is when you have to do it, when they say first principles. So the first thing you do is you write out your first principles formula. Please note that the graph is now called G, not F. So you're just replacing, instead of F, you're using G. And the first principles formula uses the limit as h tends to 0. So you're going to write, here's your g of x. And then you're going to have to use g of x plus h. Okay, so that's going to be a bit longer. So where you see an x, you're going to replace it with x plus h. And then you're going to distribute and FOIL and sort it out. So here it is. I FOILed out the binomial, and then I distributed the negative in, and I distributed that 3 in, and then just neatened it all up. So if you want, we can highlight. There's your g of x. There's your g of x plus h, and that's what you're going to substitute in. So keep the limit still. Okay, so that one's going to have the blue. It's going to be negative x squared minus 2xh minus h squared plus 3x plus 3h minus 2. Just make sure you give yourself enough space. Red. And then minus your g of x. I'm just going to have to move this. Okay, my g of x is negative x squared plus 3x minus 2. Right, so then that negative is going to be distributed. Don't forget your bracket. And then guaranteed you're going to cancel out everything that does not have an h term. So negative x squared minus 2xh minus h squared plus 3x plus 3h minus 2. We're going to get a positive x squared, a negative 3x, a positive 2. And that's going to cancel. So we have 3x minus 3x, negative 2 plus 2. And so we are left with terms that have h's in. Take out an h as a common factor. And then you can cancel the h's. Show the step before you put the limit in, where it's just negative 2x minus h plus 3. And then substitute the 0 in, which means our h is going to cancel out. We're going to have negative 2x plus 3. That is representing the gradient at any one single point on this graph. Okay, so you can do the exercise, practice the exercise there. Right, so there's the odd numbers, finding the derivative of each of the following from first principles. First thing, write your first principles rule down, write your f of x, write your f of x plus h, or if it's g or h, whatever you're working with, whatever the graph is called. You can see they've got different labels. And then substitute in. Distribute, you will cancel at a certain point where you will only have terms left over that have h's. Factorize out an h, cancel it with the denominator h, subs in the limit, and then you end up with your first principles gradient representation.